Mapping the heat flow beneath Greenland highlights geothermal freak zone. This is by Johan Unredholt, Kuznetsov, Kiel University, on phys.org. In our understanding of global geothermal heat flow, Greenland and the surrounding ocean floor has effectively been a blind spot. We know that, of course, nearby on the east, Iceland has a mantle plume under it. Iceland is a volcanic island. Now scientists have dug up all available and somewhat available heat flow data, creating common ground for working with Greenland geothermal heat as an alternative source energy source, a factor in melting of the ice cap, and much more. As it turns out that the ground beneath Greenland is even colder than previously thought, this is one of the conclusions of a paper just published in Earth Science Data by international team of scientists led by Geological Survey of Denmark and Greenland, GEUS. The researchers have compiled a new database and heat flow model consisting of all available geothermal heat flow data for the region. This involved a large amount of digging through gray literature or observations not previously included in data-scarce Arctic heat flow models. The researchers used this observation database to make a new spatial map of heat flow in and around Greenland, and the new heat flow model created with machine learning shows that the mean heat flow on land is 44 megawatts per square meter, milliwatts per square meter, meaning a thousandth of a watt per square meter, which is substantially lower than what previous models have estimated. These models were based on significantly less data than the newly published one, in which 129 new measurements are included for a total of 419 measurements. For some of the previous heat flow models, the mean geothermal heat flow per unit was several times that of the newly published estimate. Hotspots for geothermal energy. Even though the mean heat flow across Greenland was colder than previously estimated, the heat flow in coastal areas that have recently emerged from the ocean was in fact much warmer than expected. This might be good news for populations there. There's not that many people living on Greenland. Now actually this area along the west coast of Greenland has 3 times the heat flow as further inland, so it makes sense to investigate the possibility of harvesting the geothermal energy for communities located there, says lead author and senior scientist William Colgan from the Department of Glaciology and Climate at GEUS. It's a dynamic area. According to William Colgan, this makes it clear just how much we still don't know about the region of Greenland. He says, this area is a geothermal freak zone for sure. You have this really old, stable North Atlantic craton in the south of Greenland. That's quite cool, and just next to it is the Mid-Atlantic Ridge and Iceland with all its volcanic activity. Iceland, we know, is it's got a mantle plume. It's on the Mid-Atlantic Ridge. And not to mention the influence of the ice sheet, he says, all of this makes for a geothermal weird region, which is really a bit different from the rest of the world, and therefore important to understand. The geothermal heat flow, seeming to be lower than anticipated, does not change the rate at which the ice sheet is melting, he said. Much of today's melt reflects recent warming, the ice atmosphere and ice ocean boundaries. The geothermal heat flow at the ice lithosphere boundary is not changing quickly, but it's important for understanding stability of the ice sheet at the ice bed interface. Might as well do the ocean. Initially, William Colgan and his colleagues became interested in the geothermal heat flow because of its role in the dynamics of melting ice sheet. Searching for heat flow data from the Greenland area, it quickly became clear that this was a somewhat underdeveloped area, or at least disorganized. There's actually, he said, been a range of different players collecting geothermal heat flow data in and around Greenland through time, but all with individual uses. Like the oil and gas companies have collected some data to help locate pockets of gas and oil below the ground. There's also the permafrost and glaciology fields who use heat flow as an important boundary condition in their models. More or less, everybody in geosciences uses heat flow in some sense, but no one has evidently felt the need for compiling the comprehensive overflow until now, I guess, he said. He said, we're trying to locate good locations to retrieve new geothermal heat flow data. William Colgan and his colleagues had to find out where data had already been collected. The more they talked to researchers from other research fields, the more untapped data was uncovered. He says, at first we were looking for just subglacial heat flow data, then we got into data from the subaerial or tundra areas, and at last we thought, well, might as well do the ocean and cover the whole region, he says. 16 institutions and 8 countries. Thus, it turned into an endeavor expanding from the original team of GEUS geologists, glaciologists, into a range of researchers from different disciplines located in 16 institutions in 8 different countries. A joint effort resulting in the new geothermal heat flow model being the first that includes all available offshore and onshore data, including below the ice sheet in Greenland. Of course, even with 419 data points now registered for the area, the data coverage is still very small for an area as large as Greenland. Greenland has a diversity of geologic provinces and physical processes that contribute to substantial spatial variations in heat flow. A second author and doctoral researcher at the Institute of Geosciences from Kiel University, Agnes Wansing, pointed out. This is what she said, especially for the inland part of Greenland, only a few data points exist, and how they are treated in the machine learning can substantially change the model prediction. To enhance data coverage, the team is currently investigating the possibility of acquiring a heat probe to drop off the back of research vessels going on fieldwork in the Arctic. The lead author said, then we could continue to fill in the map, which is still looking kind of scarce. And as we said, this is from Kiel University on phys.org. Please leave your comments, and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.